Welcome back to the Deep Dive. Great to have you with us. Today we're taking a deep dive into what might seem like a really specific piece of industrial machinery.
Mm.
But actually, it's a fantastic example of how precision engineering, at this small scale, can have a huge impact. We're talking about the Ercolina HB60 hotshot rotary draw bender.
Right, the hot shot, and it's called that for a reason.
Okay, let's unpack this. When you hear rotary draw bender, maybe you think, super niche.
Hmm.
But this machine is kind of a masterclass in precision for metalwork.
It really is. I mean, its core job, fundamentally, is to make these incredibly tight radius bends, and they have to be consistent, high-quality bend.
In pipe tube solids, too.
Exactly. Pipe, tube, even solid bars. And this isn't just about, making things faster. It lets industries create really complex shapes with better structural strength, opens up design possibilities.
Yeah, things that maybe were too tricky or too expensive before.
Precisely.
So capacity-wise, what are we looking at? The specs mentioned up to 2-inch tube.
That's right, 2-inch tube. And 1.5-inch Schedule 40 pipe, which, that's a pretty common standard for thicker walled pipe.
Yeah.
Shows it has some muscle.
It's still going to handle jobs from, say, custom car exhausts to maybe complex railings and buildings.
Absolutely, it's got that kind of range.
Yeah.
But there's an interesting point about square tube you mentioned in the outline.
Oh, right, the tooling. It needs modifying for crush-style bends. What's that about?
Yeah, so square tubes, unlike round ones, tend to sort of buckle or crease on the inside curve when you bend them.
Ah, okay. I can picture that.
So crush-style tooling actually gently compresses or crushes the material just slightly right at the bend point. It prevents that buckling, gives you a clean corner, and crucially makes it easy to get the tube off the tooling afterwards.
Makes sense, no sticking. So speed is a big factor too, right?
Mhm.
The hotshot name implies speed.
Oh, definitely. It can bend up to 180 degrees in, well, just seconds. It's remarkably quick.
How does it do that so fast without, needing to reset constantly?
It uses this patented ergonomic function. Basically, it gets rid of the old slow ratcheting action you used to have on benders. No constant repositioning.
Okay, no ratcheting. That sounds much better.
It is. And it's powered by what they call a hybrid hydraulic gear-driven action.
Hybrid hydraulic. So, the best of both worlds. Power and control.
Exactly. You get the raw force from the hydraulics, but the gear drive gives you that smooth, really precise, controlled motion. And that directly impacts the bottom line, more profit, better quality products.
Okay, so it's fast, eliminates ratcheting. Great. But if you're bending that quickly, how do you guarantee accuracy? Making sure every bend is identical.
Good question. That's where the precision features are key. It's got this really clear angle degree wheel, easy to set, easy to see.
Like a big protractor on the machine?
Sorta, yeah. But it also has an auto stop function. You dial in your exact angle, say 92.5 degrees, and the machine hits that spot and stocks. Every single time. Repeatable bends.
Set it and forget it, almost.
Pretty much. For industries where that kind of consistency is vital, that's gold. Plus, it draws the tube from just one direction.
How does that help?
It just makes sequential bending much easier. If you're doing lots of bends on one piece, the workflow is smoother, less handling.
Okay.
And there's the swing away counter-bending die vise. That just makes getting the material in and out much, much easier, less wrestling with the workpiece.
Convenience matters in a busy shop. Now, you mentioned tooling earlier, the quick change system, and something about bronze.
Ah, yes, the tooling. It uses Ercolina's standard quick change system, which is handy. The tooling itself is often one-piece cast steel, very tough.
Right.
But that counterbend die, the part that supports the outside of the bend, is often solid bronze.
Why bronze specifically? Seems like an interesting choice.
Well, bronze has natural lubricity. It's kind of self-lubricating, so it reduces friction against the tube during the bend, which means less wear on the die itself, longer tool life.
Clever. Less friction, less wear, smoother bends, maybe?
Exactly. And the machine itself is built tough. The case has a high-section modulus design. Bit technical, but basically means the frame is super rigid, resists twisting and bending forces really well.
Built like a tank, then.
Pretty much. And another really smart feature, the whole bend head swivels.
Swivels? How does that help?
Think about bending a really long piece of pipe in a small workshop. You might run out of room, right?
Oh, yeah. Definitely.
Because this head swivels, you can position the machine to fit almost any shop space or workflow. It's very adaptable.
That's actually really practical. And electrical options. Looks like it covers standard voltages.
Yep. 120-volt single phase, common for smaller shops, or 480-volt three-phase for more industrial setups. One thing to remember, though, The capacity ratings, like that 2-inch tube, are usually based on standard steel, like A53 grade A.
So if you use tougher materials.
Right, if you're bending something with higher tensile strength, stainless steel, for example, the maximum capacity might be a bit lower. Just something to keep in mind.
Okay, that makes sense. Material strength matters. So, wrapping this up,
Mhm.
it seems like this one machine, the Ercolina HB60, really packs a punch.
It absolutely does.
It shows how something quite specialized can massively boost precision, speed up work,
Yeah.
basically delivering quality and helping businesses make more money. It's a neat example of that hidden engineering all around us.
It really is. And it brings up a thought, maybe for you listening. When you look at everyday things, furniture, cars, bikes, whatever,
Mm-hmm.
how often do you stop and think about the actual tools, the machines, like this one, that had to be designed so cleverly to make those parts, the precision behind the product?
That's a great point. You see the final thing, but rarely the ingenuity of the tool that shaped it. Makes you appreciate that invisible layer of engineering, doesn't it?
It really does. Lots to think about there.